Welcome to Math with Professor V. In this video, we're going to learn about a special kind of substitution, namely letting t equal tangent of x over 2 to help you solve more integrals. And this method of substitution is credited to German mathematician Karl Weierstrass. I hope I'm pronouncing that correctly. And he basically noticed that when you make this substitution, you let t equal tangent of x over 2, it converts any rational function of sin x and cosine x into an ordinary rational function of t. So we're going to work through a few integrals. The first one that I'm going to solve for you all is an indefinite integral, 1 over 1 minus cosine of x dx. And if you notice here, our normal integration techniques are not really helpful, because I can't do a u substitution. There's no sin x or something else sitting up there in the numerator. And you can play around with it a little bit. There may be some other approaches, but this substitution technique, it makes for like a really clean integral. So it enables us to rewrite the integrand as a rational function of t without any trigonometric functions in it. So how exactly do we do that? Because notice we're making a substitution that involves tangent, and I don't even see tangent here, right? So it's a little peculiar. So I'm going to develop all of the formulas necessary to make this substitution for you, and then we can just reference them throughout the rest of the video because we'll do more than one integral right now, okay? So here's the process, here's the idea. If we're going to let t equal tangent of x over 2, and when we make this substitution, we restrict x to be between negative pi and pi. That way, basically, this argument here is between negative pi over 2 and pi over 2. So tangent is well defined, and we're within one full period of tangent. I'm going to draw a triangle. Okay, there's a couple of ways you could derive the following relationships that I'm going to show you. You can use either a triangle or just manipulate trigonometric identities. I like a good old triangle. So notice we have tangent of x over 2. So x over 2 is my angle. And tangent of x over 2 is equal to t. I want you to think of that as t over 1 right now, okay? So that means the ratio of the opposite over adjacent side is t over 1. And then using the Pythagorean theorem, we can find that the hypotenuse is the square root of t squared plus 1. Lovely. Now what I want to do is figure out what is cosine of x and what is sine of x based on this substitution, because notice here in my integral, I'm trying to replace cosine of x with the appropriate expression in terms of t. So let's reference our triangle now. Cosine of x over 2, well, I know cosine is ratio of adjacent over hypotenuse, so that would be 1 over rad t squared plus 1. But that's cosine of x over 2, and I need cosine of x. So we're just going to use a double angle identity. So cosine of x is cosine of 2 times x over 2. Yes? Very good. So then we have 3 versions of our cosine double angle identity. I'm going to use the one that only involves cosine. So I can replace that with 2 cosine squared x over 2 minus 1. So remember here, this argument, x over 2, I'm going to carry down. And then now I actually already can replace all of cosine x over 2 with 1 over rad t squared plus 1. So then this is going to be 2, 1 over rad t squared plus 1 squared minus 1. And then continuing, this is going to be 2 over, now I have no more radical in the denominator, t squared plus 1. Let me get a common denominator, so minus t squared plus 1 over t squared plus 1. And then when I combine like terms in the numerator, this is going to be 2 minus t squared minus 1. So 2 minus 1, that's going to give me positive 1 minus t squared over, I could leave it t squared plus 1, but most of the time when you reference these formulas, they'll write it as 1 plus t squared, just to look a little more aesthetically pleasing. So this is cosine of x. Interesting, huh? Okay, similar process we're going to use now to find sine of x. So let's hop back to our triangle. And I know sine of, first I have to start with x over 2. Sine is the ratio of the opposite side over the hypotenuse. So sine of x over 2 is going to be t over radical t squared plus 1. And then from there, again, I want sine of x, which is sine of 2 times x over 2. And that's 2 sine of x over 2 cosine x over 2. Only one version of double angle identity for sine. And then now I'm just going to go through, substitute in. We'll have 2 times, so sine of x over 2, all of this, I have it right here. So that's t over radical t squared plus 1. And then cosine x over 2, do you remember where it is? It's right here. 1 over rad t squared plus 1. And then notice the denominator, it'll just rationalize itself, so beautiful. And this is 2t over, and I'll make the denominator match here. I'll just write 1 plus t squared. And this is what sine of x is. So let's just summarize that at the last step so nobody forgets. That's what sine of x is equal to. Good? All right, the only other thing we need is our related differential. I need dx in terms of t and dt. So remember, our original substitution was that we had let t equal tangent of x over 2, yes? And remember, I've restricted my angle on x, so it is within the range of tan inverse. So I'm allowed to take tan inverse or apply tan inverse to both sides. So we have tan inverse of t equals, and then tan inverse of tangent of x over 2. And then here we're just going to have x over 2 equals tan inverse of t. Now let's go ahead and differentiate both sides, okay? So if I take the derivative of the left-hand side, that's going to be 1 over 1 plus t squared dt. And then derivative of x over 2, just think of it like 1/2 x. The derivative would be 1/2 dx. Good. And then now I can isolate dx, my differential. So dx equals 2 dt over 1 plus t squared. So these are pretty much like the 3 key formulas that you need when you want to take your trig integrand and rewrite it as a rational function in terms of t. And notice it was all based on making this substitution, t equals tangent of x over 2. You don't have to actually have a tangent in the integrand in order to make this substitution. So it's a bit unique in that sense. If you haven't seen it before, you probably wouldn't have thought of it on your own, which is why let's give credit to our German mathematician here, Weierstrass. I think I'm not butchering it too badly, but I'm sure I have some German subscribers. They can correct my pronunciation. So from here, let's apply this. If you want to memorize these formulas, feel free. I think it's better to understand their derivation and the process I just showed you, because unless you practice it often, I don't think you're going to remember the formulas, even if you memorize them for a week. Long term, that's not a good strategy. So just remember the derivation, remember what the substitution is, and then you just draw the triangle, and you should know your double angles and all that good stuff. Okay, so back to the problem that I posed in the beginning. Example, we're going to evaluate antiderivative 1 over 1 minus cosine x dx. And I'm going to use the substitutions that I derived up above, okay? So we have here integral 1 over 1 minus, now remember cosine of x was 1 minus t squared over 1 plus t squared. And then dx, well, we have it right there. It's 2 dt over 1 plus t squared. Good. You know, there isn't too much to do. because I'm going to take this 1 plus t squared and distribute it through the denominator, and that will automatically help clear up the complex fraction situation. Do you see that? So we have now in the numerator just a 2 dt, and then distributing now I'm going to have 1 plus t squared minus, and then be careful, put parentheses here. This 1 plus t squared cancels with the 1 plus t squared in the denominator, but that negative is going to need to distribute to the 1 minus t squared in a hot second, okay? Good. So let's see, what do we have now? So I have 2 dt over 1 plus t squared minus 1 plus t squared. So these lovely little ones cancel out. Okay. And then, it's kind of funny now, we have 2 dt over 2t squared, correct. Okay, well, those 2's can cancel out. They're not doing anything. And then let's get ready to evaluate this integral. I'm going to rewrite it as t to the negative second dt, okay? And then from here, okay, add 1, divide by the new exponent. It'll be negative t to the negative first plus c, since I gave you an indefinite integral. And then I can rewrite this, negative 1 over t plus c. And then now it's time to replace t with, yes, tangent of x over 2. That was the original substitution that we made, plus c. Now, no, you're not going to leave your answer like this. Rewrite your trig function as cotangent. You don't want to leave a trig function in the denominator. So negative cotangent x over 2 plus c. And we're done. Okay. So that's the first little integral I wanted to show you. And again, you know, I think if you haven't seen this, it might not occur to you, but it's a lovely little technique. Just keep in mind you don't have to necessarily have, right, tangent in the original integrand. You can still make this substitution. Okay, one more example, a little bit trickier. Example 2. I rather liked this one. Integral 1 over, this is 3 sine x minus 4 cosine x dx. If you want to pause the video and try it on your own, you're going to replace sine x and cosine x to be in terms of t using the substitution that we described earlier and the formulas we derived, and then dx as well. Okay. So here we go. We have integral 1 over, this is going to be 3 times, now sine of x is 2t over 1 plus t squared, minus 4 times cosine x was 1 minus t squared over 1 plus t squared. And then dx is 2 dt over 1 plus t squared. And then similar to the last problem that we just did, if I distribute the 1 plus t squared from dx through the denominator, it'll clear up the fact that we have a complex fraction right now. So this will be just beautiful. So we have integral. Let me put 2 dt up top. Okay, and then this just all cancels. Oof. I want to have like cancel party theme music when I make a video or when I'm lecturing, because I always call it a cancel party. It's so fun. I think we need some sort of beats. Okay, 3 times 2t minus 4 times 1 minus t squared. How we feel? I feel like it looks fabulous now. So then this is integral 2 dt over 6t minus 4 plus 4t squared. So now I can factor out a 2 from everybody in the integrand, and then I'm going to rewrite the denominator in descending order. So we'll have dt over 2t squared plus 3t minus 2. Okay, so here's our rational function, very cleaned up, all in terms of t. It's definitely time for partial fraction decomposition. I can see that it factors. Do you? Our integrand is 1 over 2t minus 1 times t plus 2. So the partial fraction decomposition will have the form a over 2t minus 1 plus b over t plus 2. I'm going to multiply through by the LCD, so 2t minus 1, t plus 2. And then this is going to give me 1 equals a times t plus 2 plus b times 2t minus 1. And then to solve for the constants a and b, I'm just going to let t equal negative 2 first. So then I have 1 equals a times 0 plus b times negative 5. So I know b is negative 1/5. And then similarly, I'm just going to let t equal a half. And then I have 1 equals a times 5/2 plus b times 0. So a is positive 2/5. Good. So then let's rewrite our integrand. If that was too quick, don't worry. I have a video on partial fraction decomp linked in the description, okay? I'm assuming you're watching this video and you're pretty good at all the basic integration techniques, but if not, I got you, okay? I got so many videos, just check the description. So we'll have integral 2/5 over 2t minus 1. And then b was negative, so you know what I'm going to write? Minus 1/5. Are you all okay with that? Oh, good. Thank you so much. dt. Yes? Let me take the 1/5 out. Out. 1/5. 2 over 2t minus 1 minus 1 over t plus 2. Oh, I like that so much more, don't you? Good. Then, here we go. Time to evaluate this integral. 1/5 natural log. I have absolute value 2t minus 1. And then normally we would divide by 2, right? Because of the 2 in front of the t. But then I have a 2 here, so it all just cancels out. So I'm going to have natural log absolute value 2t minus 1 minus natural log absolute value t plus 2 plus c. If you want, we can combine these into a single logarithm. So 1/5 natural log absolute value 2t minus 1 over t plus 2 plus c. And then now we do need to go back, replace t with, yes, tangent of x over 2. So we have 1/5 natural log absolute value 2 times tangent of x over 2 minus 1 over tangent of x over 2 plus 2 plus c. Voila. I think that was lovely. Hopefully you enjoyed it. I have 2 more that I'm going to solve, but I'll make a part 2 of this video. And if you want to try them on your own and see if you can solve them before I upload, please feel free. So we have coming next. Look at that, I'm doing like a trailer, teaser. Coming next, we have number 1, integral pi over 3 to pi over 2, 1 over 1 plus sine x minus cosine x dx, and 2. Yes, I'm giving you both definite integrals. 0 to pi over 2, sine 2x, over 2 plus cosine x dx. And some of these you may be able to do a different way. You may not need to use this substitution, but I'm just going to keep practicing and showing how it works ever so beautifully for these 2 problems. And funny enough, I did say, here's a little trailer for what's going to come. You know, movie trailers used to be at the end of a film. That's why it was called a trailer. You know, it was following. But then I don't know exactly what the reason was. Maybe people didn't stick around, so they started putting them in the beginning. But they did used to be at the end as something that trails would be, following something else. Anyways, that's that. That concludes the video. If you enjoyed it, please give it a thumbs up. Subscribe if you haven't already, and share this video and my YouTube channel with your fellow classmates, friends, neighbors, barista, you name it. They probably would benefit in some capacity. And if you need more review of integration techniques or any other calculus topics, I have video lectures organized into playlists. So just go through either Calc 1 video lectures, Calc 2, Calc 3. I've got so much stuff here. And please follow me on Instagram, TikTok especially, and Twitter, Math with Professor V. I'm trying to hit 10K on TikTok sooner than later, guys. So please give me a follow there. I would so appreciate it. And I love you all. Bye.